Thanks so much for having me. So I think that you got the long bio intro versus the short one, which is this. We'll start there. So I want to talk to you today about LLMs specifically. So there's going to be no ODEs in this one. There'll be no brain imaging, sadly, but it'll be a different change of pace. So I primarily work in natural language processing. I don't know if you've heard of large language models lately, but they're good at a bunch of different things. So if we think about good, and I'll say good with a caveat, we should always think that you should lightly skeptical or heavily skeptical. What are people using them for? Well, there's the ChatGPT guide to dating. That's probably going to be successful. Maybe ChatGPT can replace your therapist. Also, maybe that we should think about that. But things like having these large language models be useful for NPC or non-player characters in gaming. I think it was Carl's Jr. that replaced their drive up with a large language model to take your order. There's a lot of things that these models are being used for in different kinds of roles. And ideally, we want the models to assist us. And so there's a lot of work coming out in this space called agentic AI. We want models to be able to interact with us in different ways. So there's fun on like customer support agents. And does anyone use Perplexity? It's like a related works engine. Yeah, it's useful. Open Hands, which is a agentic software developer. You say, hey, go fix this bug, and it does it for you. There's one for HR. Nothing can go wrong there, having your HR replaced with an LLM. But there are all these agentic systems. And ideally, we do want these to behave in ways that are socially appropriate. So we try to outline some of the different ways, thinking about, the models have linguistic knowledge, and we deploy them in lots of different ways. But really, there's a lot of social context in which they're used that makes a big difference. If we unpack that, it really should impact how we evaluate them and how we deploy them. And there's a whole host of things that show up in that social factor. That's, what is the LLM trying to do? What are its goals? What are the norms in which it operates? And who are the speakers and receivers? So for this talk, I'm going to think about, what do we really want from these models if we deploy them in an HR setting? Well, we'll talk about what do we want from them in two ways. One, I'm going to think about part one, thinking about behavior. So who do we want them to be? And if we ask them to be a certain group or a certain person or behave in a certain way, will they do that? Will we actually get the behavior that we want back out? And the second one, I'll think about action. So if we think about these as agentic systems, will they actually help us in ways that we really want and that others find, on the judgment side, to find to be helpful? So I'll try to look at these both separately. And I'm going to start with the first one. I'll say some of this is work that's really recent, and some is like really, really recent. Like I got the slides yesterday, as James was we were chatting about. So this is work that's not yet published. It's in the works. So I welcome questions throughout. So let's look at this first one on behavior. I'm going to look at two specific kinds of questions here on how we want language models to behave. And the first one, we'll think about models role-playing to be more effective at tasks. And the second, we'll talk briefly about taking on different groups' perspectives. So I don't know how many of you have played around with these large language models. You probably use them, like ChatGPT is everywhere. And most models actually have what's known as a system prompt. How many folks have heard of a system prompt? Handful, maybe? Oh, nice, okay. So, if you say to ChatGPT, revise the following paragraph, maybe under the hood, it's got something like, you are a helpful AI chatbot. Be honest in what you write. And then it kind of goes off. And it's kind of like high-level guidance to a model for what general things should it do or how should it behave when it does any general specific kind of task. And these things control quite a bit about how they operate. So don't read this text just yet, but there's a large design space for how we might think about steering these models. So, there could be things about the persona. So your task is to respond in a truthful manner. Please make sure you provide diverse and informative responses. They could be attributes and qualities. It could be something about, safety guidelines. So don't say falsehoods. If you don't know, say so. And there could even be output and formatting guidelines. So I'm going to give you some idea of how we might try to use these system prompts. I think more generally as well, when we think about large language models, these are big. And so there's kind of two ways to think about how we might use or design them. There's one is you have a big model, like ChatGPT or one of the very large llama models, and you sort of steer that ship, and these prompts give you a way to move that into a new parameter space. There's other alternatives called mixture of experts, which also large language models will use too. You can think of this as, can I use these system prompts to get me little experts if you want? So this is applicable in both of these domains. We're going to think about steering the ship into a direction or behavior that we want in general. So in this first one, I'm going to think about trying to tune the social role of the agent. So I want you to answer a question. So how many valves does a human heart have? And how much milk does a cow produce per day on average? If you think about who might answer this question best, if you just asked a person on the street, it might be a different person for each question. Like, I don't know, my cardiologist should probably answer the first one. I don't know if he would know what with the second one. So maybe we could try to take advantage of this. If we want an agentic system, we want them to behave with a certain set of cultural or social or just theoretical knowledge. And so maybe we could try to adapt a person to the domain of the question. This kind of mirrors the rationale behind chain of thought. If you think carefully step by step, turns out it has a lot of benefits. If you've heard about the new DeepSeek model, this is based on this reasoning process, and that reasoning may vary based on who you ask the model to be. So maybe we kind of think of it as just we're going to get the right answer by asking the right person. So we said, hey, what kind of social roles might we think about in practice? Well, we took a bunch of different occupations and a bunch of different relationships, like my mom. What happens if I ask my mom? She knows everything. And we'll also group these into different kinds of categories to see, do we see group level effects as well? So there's kind of a few key questions. Are some roles more accurate? Maybe my mom does know everything, and asking ChatGPT to be my mom will give you the best answers. And then we can think about whether the in-domain roles actually help a little more. If I'm asking something about an ODE equation, maybe asking someone in the engineering department might be more likely to answer it correctly. And we'll test this on a data set called the Massive Multitask Language Understanding, or MMLU. It's got a bunch of different domains. It's really hard for large language models. And we'll test using a variety of different open weight models. So we're not going to use ChatGPT, but we will use a bunch of these. You can run them on your laptop or really high-end GPU too. So let's just start with the first question. If I ask the model to be agentic, if I ask it to take on a certain role, does that help me in general? So on the x-axis, I'm going to show you a bunch of different models, from an 8 billion to a 70 billion. On the y-axis, we'll look at the number of roles that have no effect on the overall accuracy, statistically speaking, like a p-value of 0.05, have a negative effect, or have a positive effect. Any guesses? It should be primed a little bit of like, what do you think might happen? Well, let's look at FLAN T5, or yes, FLAN T5 11 billion. It's a pretty big model. It's either no effect or negative, 70%. So asking a model to be my mom doesn't help. Asking it to be a math teacher doesn't help. So okay, there's no one role that seems to help in general. What about the rest of them? Haha, unfortunately that pink bar of positive effect was a decoy bar. It does not seem to help. Actually, there might be like a 1 down here somewhere. I don't know. Let's look in the data again. But for the most part, asking these models to take on agentic roles seems to generally hurt across the board or have no effect, even though we're looking at a bunch of different domains. So that kind of should give you a little bit of pause. What if we just, okay, let's look at some role categories. Maybe any individual role is not helpful. So we have a few different here. This is going to be a regression where we're going to regress out the relative differences in the model as a random effect. And then we'll look at the category of the role directly. So can we just look at category effects? If you'll notice here on the the x-axis, this is going to be the change in accuracy. We'll have a dashed line for 0. And if we ask the model to be, this is relative to just being an AI. So you can be an AI, not to no role. We do see that asking it to be a boss or a coworker, that seems to have a little bit of a positive effect comparing a model to be a helpful AI assistant. So there is something that we get a benefit from by asking a model to be more human-like relative to being more AI-like. But if you look at the x-axis, it's still really small. We're talking like, almost like a rounding error in your overall performance. So these like personas that if we ask models to be more agentic with the persona, not much. But maybe if we ask the model the right role to take. So if you're like, how many valves does the human heart have? If I could get the right person to answer that, I would do much better. So what happens if we choose a random role? Relative to no persona, a random role is worse. We basically make things worse. That's unfortunate. What about the best role in the training set? So the role that was most accurate in our data? No. And if we try to predict that role directly, it's even worse. So that's not helpful. What about if we at least give the model the domain, we know this is a math question, which of these math-related things or roles might you pick? Or we try to choose a role that's most similar to the questions using some like NLP stuff. No. I'll say this is a pretty good high-performing model. If we could actually specifically identify the best role per question, we actually see a pretty good improvement. But it turns out like finding that best role is non-trivial and doesn't seem to work. That's kind of depressing. So that's a nice negative result, but it suggested this agentic tuning where we're like, let's get the best role. You want to be a helpful writing critic or a good teaching assistant. Those in general aren't really giving us much benefit and often just are kind of hurting our performance. Okay, well, you know, if you think about what these models are doing, there's all sorts of things that we're asking them to do. So maybe we can ask them to be a helpful assistant. Well, maybe there's lots of stuff we could do. And so these system prompts really take on a set of diverse functions from the persona, which I just showed, to style and emotions, the chain of thought, like let's think step by step, that often triggers reasoning in models. So maybe instead of just trying to just pick one, maybe we could try to learn a system prompt. We're going to try to combine all these different design elements together and see if we could actually do it. So I'm going to give you a sketch of the algorithm. You could think we're going to start with a large pool of 9,000 different properties for what a model might do. Could be helpful. It could be think step by step. And then we're going to train what's known as a rewards model. This is going to be an estimate of like how good do we think this model, this system prompt is going to be on a bunch of different tasks. I'm not going to tell you too much about it, but you can think this is a standard supervised machine learning where we've actually run some of these in practice. So we'll create a bunch of these like prompts to train this model with between 1 and 30 of the properties. So pretty long system prompts with a variety of different instructions. And we'll run that through some benchmarks and say like, yeah, these are better or worse than each other. And then we'll try to generate this prompt directly. So we'll start with all of our different potential instructions. You can think different steering instructions. And we'll try to run a hybrid reinforcement learning and genetic algorithm to basically extend the prompt or modify some of the components or drop some of them. I'm not going to go into details of this. There's plenty in the paper. It's the end of the day, so I figured we already saw ODEs. We don't need to see more equations. But you can think this works in practice. And we'll basically kind of keep around some of these system prompts that look like they're doing pretty well. And we'll just kind of keep running this over time and iterate again, maybe 30 iterations. So you can think this is like, again, general steering of the model. Can we get it to perform better in practice? So what happens? Could we actually get better model behavior by learning a system prompt directly? So let's start with our base. Let's just ask the model to think carefully step by step. That was kind of the first early paper. It seems to, on this reasoning process, it seems to work pretty well. What we find is if we can optimize it further, we will do better than that base one. I'm going to show you a comparison. This is called Protege. This is what's called a task optimizer. For each of the different 50 tasks, I'm going to try to directly optimize my prompt for that task, ignoring the you're a helpful assistant. So this is a really competitive baseline that's saying, you know, I know exactly how to optimize my instructions to make the model do really well. Versus the blue bar, which is like, you know, just do the task, but anyway, you should be helpful and thoughtful when you do it. It works about as well, that works about as well as the task optimized and definitely better than the chain of thought. And we could even combine them further. So we could actually say like, well, let's start with the general set of really good instructions and then optimize that further. And that gives us even better benefits. They're small, and there's a lot of noise in the data due to heterogeneity in the tasks, but it actually kind of works. And surprisingly, it works quite well across different kinds of model families. So on the x-axis here, this is how many steps, like how many modifications we've made to the system prompt. And in just a few steps, we're getting, you know, 6 points of improvement for Llama. We're getting, you know, another 6 or 7 points for the Quen model. So this is pretty good that we can actually get, you know, roughly a 10% boost in improvement with only a few tweaks to our system prompt. So saying, be helpful, you know, think step by step, and we're learning that directly. Those aren't the exact instructions, and it does vary from model to model, but it suggests that we can steer the model in the right way. So going back to our initial questions, can we actually tune these models to better align with specific groups or characteristics to get better performance? Personas, not really. It seems like if we want to do this, trying to get domain knowledge out of it doesn't seem to work well. And in fact, it seems to only minimally impact these factoid-like questions. We can actually get some generic response, some system level behavior. So if we actually try to use the genetic algorithm reinforcement learning approach, we can actually generally improve performance, but it's not optimizing for a particular persona. So it suggests that there's a broader set of behaviors that we can evoke from it that generally work well. That said, I do think there's a lot of opportunity here for thinking about how to get new models that can adapt to the context and the tasks that they want to get in. So this agentic system will be pretty useful in the future. So with that, let me try to move to this second point in the part one of behavior. Can we actually get LLMs to take on the perspectives of different kinds of people? So this is pretty useful, but let me give you an example task. Let's say that I want you to think about reading an email. Probably get a bunch of emails from UB, you read some of them, others you kind of like that can sit unread for a while. You might think about, how polite is it? How offensive is it? Am I inclined to click on some link in it? Will I buy the product in it? And if you ask enough people, you're going to get a bunch of different answers to that. In traditional machine learning, we often think of we have to aggregate these into a single label and then we'll train our model. But really, not all of those disagreements are wrong. And some of them vary by group, some vary by individual characteristics. And we like to be able to model that diversity in responses pretty effectively. This is often very important for thinking about the kinds of ways that we get disagreement. So we and many other folks have said, well, could we actually get large language models to simulate different demographic personas? This is pretty useful in many applications. Marketing folks would love to know, can I tune this kind of, if I think about would I click on this or buy something? If I switch out the demographics, can I tune this to get a yes answer that I'm going to buy it? Survey estimates would love to know this, of trying to simulate hard to reach groups. Folks in forecasting would love to be able to simulate different types of trends and behaviors. So if you want to try to do this, you might say, well, you're a 40-year-old white man from the US. Will the model answer in the same way that a person of that characteristics would do? So our key question really is, do models have enough knowledge to do this? Large language models are pretty trained on tons of data. Some of it is from different groups. Could they actually do that simulation? So we're going to test this with a data set known as Popcorn. So it has 4 NLP tasks. We're going to look at 2 of them. It's around 45,000 annotations. We're going to look at 2 of them, one on offensiveness and the other on politeness. This is sourced from Prolific, so we can get a US representative sample that has a ton of variety of people. And we're going to see whether models can actually align with the answers and the differences that we see from the groups in this data set. So we'll try on a few different models here. I'm going to show you a handful. There's more in the paper. We're going to look at Flan T5, Tulu 7B, which was supposed to have more diversity, and 2 of the larger GPT models. There's not 4.0 here or 4.0 mini. That may have changed as well. And we'll just try a simple prompt. We tried a few in the paper, but how would a person of this type, you could say a 40-year-old white man, rate how offensive or polite the sentence is from 1, not offensive, to 5, very offensive. And we'll swap out offensiveness and politeness. And what we'd like to know is how aligned is the answer with the ground truth population's answers. So we'll think about correlation. So how correlated are the answers for specific subpopulations? So we'll get essentially different estimates for each subpopulation of how offensive this item is or how polite this item is. They're different items too. One's emails, the other's like Reddit messages. So let's start with this first question. So are an LLM's default perceptions of offensiveness more aligned with certain groups? I'm not going to demographically prompt it. I'm going to say, do you think this is offensive or not? I'll say that the data itself, the survey data, did include non-binary options, but in the Prolific sample, no one self-identified as non-binary, so we were only showing men and women. That's what's in the data. So let's look at this. On the x-axis, this will be the 4 models that I'll show. On the y-axis, this will be the correlation. How correlated are they with the subpopulation's ratings? And what we can see is that it's not uniform. On average, if you take the average, the models, so larger models are better. But if you look at the difference between the green and the yellow bars, you consistently see that models' default ratings are more correlated with women's perceptions, which is interesting. Some of that may have to be, well, there's lots of different potential explanations for what that is, but we suspect it has a lot to do with the reinforcement learning for human feedback, or the RLHF. So trying to make sure that the model's perceptions are sort of most inoffensive. If you look at ethnicity, I'm going to show you a similar kind of plot, but it'll look a little different. And so here, you can think we have different subpopulations, but you can see that the model's output is much more strongly correlated with white annotators relative to the Black and Asian annotators in our group. Here again, I'm showing you the groups in the data that had enough ratings to get some sort of statistical significance. So this really suggests that at least for offensiveness, that the LLM baseline judgments are much closer to women and white individuals, which is surprising. Well, maybe not that surprising, but the gap itself was still quite shocking to us. That said, this is the default. Maybe models are still pretty good at doing some role playing. We could only hope. Actually, let me show you quickly what happens with politeness. Again, we saw offensiveness. What about politeness? Still, again, we see the same trend that the models are more likely to be correlated. The model's default judgments are more likely to be correlated with women annotators, and for ethnicity, again, more likely to be correlated with white annotators. So really, this is a general preference, at least for two lightly subjective tasks. So we see the same result. That said, maybe we can get these to prompt, we can prompt them to steer them to take on the perception. So for this prompting, I'm going to show you the results in a slightly different way. Again, on the x-axis, we'll see the 4 different models. But on the y-axis, we're going to see the change in correlation. So before, if a model was 0.7 correlated with the judgments of white women by default, or with women, and then I say, pretend that you're a woman, what's the rating? Now I get a new correlation for that. The fact that this is all from 0 to a negative score may foreshadow how it's going to go. What we see is if we ask a model to take on the attitudes of a particular group, it actually makes the model's judgments worse. It's even less correlated with the actual views of that group. What this suggests is, at least for gender here, that asking the model to take on that perspective is like worse than not asking it to do that to get the individual group. Kind of shocking for us. What about for the racial data? Again, even worse. There's still some slight positive one, but for the most part, asking models to take on perspective doesn't do it. These models really can't do it. So actually, asking for a specific group decreases the alignment. And I'm showing this for offensiveness here, that you see the same results for politeness. So especially for ethnicity, trying to get these differences, or say, I want to find messages that might be more offensive to a certain group. Can I do it? Can I find that disparity? We actually we'll probably have more noise in our system trying to do that persona-based surfacing. That's kind of a, question.
Are the bars on the left, are they significant?
The small ones or the large? Yes, these are significant. So
45,000, is that how many prompts are there?
No, we have 45,000 of the total data set. I want to say it's like probably a few thousand. We can follow up later, but yeah. All right. So, okay, that's a little demoralizing, because if you want to do this persona-based work, it's really helpful. I mean, there's lots of really positive things you can do. Models don't seem to be able to do it well. Well, maybe we could just train them. Like, we have demographically labeled data. Maybe we could actually just show them how to use those, like the different preferences in different groups. So we're going to try to do this in training. We'll show this as one moderately sized large language model. We use Llama 3.18 billion. And we're going to train it on 5 different data sets. So the offensiveness and politeness data I just showed you. We'll train it on intimacy. So how intimate do I think this message is? A sentiment. So there are differences in whether something is happy or sad. And model safety. Do I think this is like a rule-based judgment of whether this is unsafe for a model to produce in practice? All of these have kind of rich demographic data. There's, a few 100,000 between all of them. And here we're going to try to incorporate identity in a specific way. So we're going to show the person's identity as a regular text, like in the practice, or in the previous example. But we're also going to add in an annotator ID. And I'll talk about why that's important in a second. So here we might say, like, here's our prompt. Annotator, there'll be a unique identifier for the annotator. We'll say this person is Hispanic Latino, they're 40 to 44 years old, a woman, and they have a college degree. So we have quite a variety of different kinds of preferences here, or demographics. The annotator ID is going to do something like capture the idiosyncratic preferences. So I'll make an analogy to, say, recommender systems. So if you've ever used Netflix, you have your own preferences. If I ask whether you like, say, Harry Potter 7 Part 1, maybe you just really like those movies in general. But the demographics are going to be capturing sort of group level variation. If I ask a 10-year-old versus a 90-year-old whether they like Harry Potter, I expect kind of different average ratings for that question. And so we want to try to model both. So how this specific annotator rated something, and then how the groups that they're a member of rated something, whether they have a college degree, whether they're a certain age range, that sort of thing. In this case, we're going to try to train a bunch of models to get more power. So we'll train 20 models for each, with each different seeds, and then we're going to try to match the annotator's exact rating. As a baseline, we'll compare against what if we just didn't use a persona, and then we'll train with just the annotator ID alone. So maybe if we just try to capture your idiosyncratic variation, that should give us some sense of what the performance is. And then we'll also train with the annotator ID and the demographics. But then we'll use two different settings. So this will be useful later to show in a second. In one, we'll kind of use your standard machine learning split. So we're going to split the instances split our training data by instance. So we'll have totally unseen instances that we want to say, can we generalize how our annotators that we know would predict on these new instances? The second one, we're going to split by annotators. So we're going to say, hey, we know something about, we've seen this instance before, but we have a wholly new annotator whose demographics we've seen. So I don't know anything about your idiosyncratic variation, but I can tell from your group membership how you might rate this higher or lower in practice. So we've seen the instance before in the annotator split. So let's take a look at some examples here. So can models learn demographic preferences? This will be our instance split. This is your standard machine learning setup. Whoops, that was a spoiler alert on the left. So we see here we're going to have our, on the bottom, on the very bottom bar, that's our zero shot. This is how well Llama does in general. The blue bar right above it is just we're going to fine tune only on the content. Models can learn the task pretty well. This is averaged. This is on the intimacy data. That yellow one at the top, I think you can sort of still see it. This is with the ID and the attributes. We're telling you your annotator rating, and we're going to tell you, all your characteristics, and that your annotator is 72. What's missing is just the ID. How well does the ID do? It's right there. So you're like, uh-oh, my demographics didn't seem to help much. What's going on there? So if you didn't have the ID, you might be thinking, well, the demographics, great, it's really helping. But adding the ID doesn't seem to do much. Or just the difference between the attributes and ID. So it's what's going on there? And we see the same trend for all the other data points. The second one, again, you see basically the yellow and the orange are basically always near each other. So adding this annotator ID seems to be helping in practice. It looks like the attributes, that red one, gives us a lift. So it's oh, that's helpful. What's going on? So let me give you, so it really seems to be that models are learning the demographics as a proxy for the annotator ID. They're not really learning much about how the demographics change that annotator's rating, but there are only so many white men who are 40 to 44 years old who have a college degree in our data set. And it turns out there's only a handful. You could just say that string is this guy. So just keep predicting his idiosyncratic behavior. Yeah, question?
So the annotator ID is sort of an indicator of a constellation of characteristics.
So the annotator, you're annotator 73 and I'm annotator 74. It's just the number. Just the number. It's a lot, yeah. This is a demoralizing result because of that. Yeah. Thank you for the clarification. Anyone else, feel free to raise hands. Okay, so let me show this other setting of what happens if we try wholly new annotators. I've seen the text before. I should probably be able to predict it, but I have never seen this annotator before. The annotator ID should be pretty useless. I'm I've never seen annotator ID string 75, so I don't know what to do with it. But, I have seen demographics before, so I've seen how other white men of age 40 to 44 rate this item. So if I learned anything about that, I should still see a gain. What do we see in this first data set? Oof. basically, we get an improvement from training, but all of our bars are basically stuck in that bottom corner. We're basically only learning how to do better in the content. The annotator demographics and the annotator ID are basically performing the same. We're getting no benefit for demographic training. And we see the same result across all the tasks. So this again suggests that models, prompting them with demographic information, even if you're doing it, unless you have a ton of it, suggests that models are really just learning this as proxies for idiosyncratic behavior. And we think some of the earlier results that suggested you could do this by training forgot to control for the fact that individual people vary, and they probably just have enough sparsity in their data that they're learning this. Ugh. So I feel like it's all negative results. Let me show you some more positive results later. But going back to our major questions, can models role play as identities? Well, they don't seem to be well aligned to do this in the zero-shot setting where I've not trained them to be, even for large models like GPT-4. And if I ask them to take on specific groups, that makes it worse. They're like even worse at getting that group's preferences. And if you think about, okay, we could train them, so I could try to learn this. It turns out actually models are learning demographics as identity. If we had even more data, maybe we'll be able to get at it, but we don't have that data sitting around, so it's really tough to test that. So can models effectively role play as identities? No. Sad negative result, but useful to know because these are really beneficial applications, particularly in the business setting and the survey sciences and the social sciences. So tell your friends, I guess. But okay, on that note, I'm going to try to move to the second question, which is like really new work on thinking about how we might still make these models helpful for us, even though they can't behave the way we want. So again, I'm going to go back to this agentic perspective, that we have these AI systems that can kind of sit alongside us and help us do things like program. I don't anyone know uses agentic AI programming? I do. It's great. I hope you do too. No, not for your classes. And we have these systems that are kind of like all over the place for communication even. So, we have the new Apple Intelligence like auto suggests. Gmail Smart Compose will try to finish the sentence for email. The Google phones now have something too. And these are actually helping us maybe nudge that you were going to say something like really curt, and the model like finishes it really nicely. You're like, okay, I'll just send this like slightly more polite than I would have intended email back. Maybe that helps. So we really wanted to think about this at scale. If anyone's talked to anyone else online lately, things can go very badly. Maybe you had a good conversation online. Congrats, you're probably not in the majority there. And we thought, okay, maybe we could get AI to help here. That's the wrong question for most situations, but we're still going to try. So imagine that you're having this discussion, cats are smarter than dogs, and it kind of goes on for a while, and you want to comment on it. You go to some box, and you want to type something here. We could think maybe we could try to assist people when they respond to this with some AI. And there's lots of different ways that we might think to do this, where we're not wholly replacing the person. So maybe we could start by suggesting potential responses to them. This is like Gmail Smart Compose. It's like, hey, you could just reply directly with this kind of message. Hopefully personalized a little longer. We might allow a person to get feedback. They're typing something. If anyone uses Grammarly, it's like you get feedback on your language, maybe it's suggestions for clarity. We might, get a strategy for how to start a conversation. Some conversations are hard to do. If everyone's ever tried to talk to someone who's experiencing a loss, you're kind of like, thoughts and prayers. Like it's tough to know how to cognitively engage. But maybe this is a way to make challenging conversations easier by providing a path into that conversation that's lower effort. Or maybe you just need a chatbot on the side because you're like, someone asked something really complex and you're like, I don't know what that is. Hold on. And you just quickly type it. So these systems can sit alongside of us in many different ways. And we said, well, we'd like to test this kind of stuff. So really to do this, we need like a controlled social media environment. Maybe like Reddit lets us do some stuff with different AI treatments. We need different topics to control for that and people from different backgrounds. And it sounds like this is like kind of impossible. Like I'm not sure we could get any social media platform to take us up on this. So what do? Instead of give up, we decided to do the stupider thing and actually just build a social media platform. So a visiting student honors went through and just built this kind of like Reddit-looking clone that's fully functional. You can like stuff and like get different reactions. And it's all plugged into a nice system. I didn't write this system, Empirica. Has anyone heard of Empirica? It's really cool. So it's like a behavioral scientist basically lets you plug into Prolific and you basically get groups of people and dump it into an experiment. So we can get a bunch of people who come and talk to each other in our fake social media platform, but it shows up like social media, so it's like real in that sense. And we're gonna try these out. We're gonna see what happens to people's experiences online when they have access to AI. Like, do they use it? Does it make things better? Do other people like it? So we'll have a few different ones. I'm gonna kind of show you what they look like. One is suggestive responses. I realize I don't have screenshots here for everything in the whole pipeline, but a person opens that chat box and there's an AI suggest button that they can click. They don't have to use it, but they're like, what might AI suggest? They click and they get 3 different options. We've tried to get, seed them as like an agree, a neutral, or a disagree that are correlated with, or like associated with what the content they're replying to. This is hopefully, this is really low effort, but there's plenty of low effort social media posts, so maybe this is still more content related than you might get normally. We'll have a comment feedback. So here a person has said like, I think dogs are smarter on average. And then you click AI feedback and it kind of gives you some suggestions that go on for a while with like, maybe you could engage with your personal experience. And people might edit their comments. In fact, they do, although I don't have a slide showing that. And maybe if you're pretty spicy in your comment, it says like, hey, let's tone it down. Some people are cat people. They can like them too, but let's be civil here. We have our conversation starter. So you're like, I'm not sure how to respond to this. And someone's like, well, ask a follow-up or try to relate it to yourself personally. Kind of trying to lower, again, that cognitive effort required to engage meaningfully with other people. The benefit of this, still in the author's own voice. We're not telling them what to say, just where to start. And then, we'll have a general chat bot. So here's like a chat that's going on. There's something on the side where the person's like, how do I respond to this? Or what is it? And this is basically just going to be like, I think we use GPT-3.5 on the side. They don't know it, but there's just like a general chatbot in practice. So our experimental setup looks something like this. We're gonna have 5 random people, never talk to each other, from Prolific, from a US representative sample, so we get plenty of diversity in who's actually talking with each other. They're gonna talk on 3 different topics. 1, dogs versus cats. The second, the health benefits of oats. Anyone know about the health benefits of oats? Turns out most people don't. Oh, well, one person. So you would be the expert, and the rest of us would be on the ChatGPT sidebar being like, what are the health benefits of oats? And then we wanted to get something political, but not like incredibly inflammatory, because we know that will go off the rails. But we chose universal basic income. That's divisive enough that it plays on your values, and there's plenty of weird conversations or spicy conversations you could still have from that. We're going to get 10 minutes per conversation topic, so a reasonably substantial amount of chat. The topics are all randomized, so you don't stop or end your conversation always with the political one. And we're only going to have 1 AI treatment per conversation. We'll have a control group as well. Everything was optional. They had to click the button. They could click the button and still not use it. They could edit the responses, so they still had a lot of agency. And all this is instrumented, so it's still tracked somewhere. And we had 680 people in total work with this. And we had a bunch of pre and post intervention surveys about their attitudes about AI, about whether they thought the comments were helpful in the end. So we really could try to get at the change that this experience had for people. I'm going to show you some results for 2 research questions we're thinking about. I will try to answer any other questions you have on this at the end. But can we access these, how do people access these tools to increase their participation? So if they have access to that chatbot, does that mean that they're actually going to write more or engage more or comment more? And the second, if they have that access, what do other people think? They don't know if someone's written that comment with AI. I don't know if anyone's had that experience where you're like, that's a chatbot who definitely wrote that comment under this thing. I mean, people get accused of it. Professors definitely see it in homework. You know it when you see it, for sure. But then how do people respond to this? You're like, this is just a bunch of chatbots talking with each other. It's like the dead internet. So let's look at this first one. How do people feel about AI assistants as authors? So I'm going to show you one survey item. The question was, AI suggestions can make it more likely for me to participate in online discussions. I'm going to show you on the y-axis the 5 different groups. This was asked for the control before and after. No one had AI in this situation. They didn't know if anyone else had AI, but and they weren't told that people were going to use that. And then on the x-axis, I'm going to show you the change in the rating in the pre and post. So what you can see is just engaging with people online, people thought, okay, yeah, actually, AI might help. So in the control condition. For the chat, actually having access to that sidebar, unstructured chat, I could do whatever I want with it, had the most impact that people felt that having access to that changed their ability to engage. Which I was like, that was not the one I was expecting. And suggested replies that like, here's ways that you might engage with someone else. People thought that was easier. So really only these two seem to make any difference in people's experiences. What about the second one? How did the use of AI change how much was written? So we're going to look at like what actually shows up. This is our control rating. What we actually see is that AI basically lets people write a lot more. They just really, you're looking at like not double, but like 70% more in some cases. One of the interesting things though is that conversation starter. Like if I just kind of give you an entry point into the conversation, I'll tell you what to write. You still write more, and it's your own voice. So that's really exciting that like maybe this is a way to lower that cognitive effort, get more substantial or substantive kinds of comments back out. Even getting feedback. I tell you some ways that you can improve, and people do, they write more. So this is maybe some ways that we get better comments as a result. There's a lot of other things that we studied here. People write in more comments overall. They write more diverse kinds of content than they did before. So it's kind of exciting. But let's think about what the impact of this is in practice. How do people feel about reading this? So again, in the non-control conditions and the treatment conditions, people know that others might have, they know that they have access to it. They don't know when someone's using it. Nothing's flagged with AI. But let's think about what happens. I found the comments from other participants to be informative and of high quality. This is the post-conversation one. Here's our control. What do people think about the rest of the conversation? And in fact, we see it's got worse. So remember, people rated that chat one is that this made it easier for me to engage. What did the readers think? This made the conversation worse. The conversation starter, people wrote more. They were able to be easier to engage. Also, they wrote worse. What do we want? This is really crazy. So this was kind of this also unfortunate effect. Feedback, telling you how you might improve, more content, no change in the quality, suggested potential replies. These are AI responses. You're just like, you could click it, you could still edit it. No change in the quality. That's the one we thought would be most detrimental. Nothing. That's weird. So this really suggests, AI was neutral or hurtful to people's perceptions. What about, we had these reactions. What do people think? They smashed the like button. So I'm not going to show you the build out, but this is the like, love, dislike, and funny. There's a bunch more that were rarely used. These were the 4 big ones. What we see is that AI, for the most part, is much less funny. Whatever those comments, even if it's not you, like you writing with AI assistance in the conversation starter, much less funny. People do love those comments better if it's a suggested reply, which again, I was not expected. So this is just me copying and maybe lightly editing what the AI has suggested, and people are more likely to click the love. I thought those would be the worst comments. Maybe that's just, we have low standards, and we click that. I don't know. What about, does it lead to more conversation? So here's the mean number of replies. If basically every other comment gets a reply. In the control condition, what we see is if I give you feedback on how to improve your conversation, less likely to engage. If I tell you, here's the AI's response, I copy it, I lightly edit it, more likely to get a reply. We checked, it's not people accusing the other person of being an AI system, so that's like not a weird confound. But it was really surprising that what's going on in this data? So really getting feedback leads to less engagement. So if we think about can AI help us in conversation, again, let's look at these 2 pre and post. So change in I think AI can be helpful. We think people have access to chat or suggested replies, think yes. If we think about whether people found other comments in the conversation to be informative, the answer was those didn't help. So really we're getting this big mixed message of between what authors think the use is helpful for and what readers think the conversation quality is when we make these. So it's really, it's kind of a strange world. So just to kind of pop up and wrap up, Can access to these AI tools help? Yes, they can definitely help people increase their participation. People feel this way. We see it in practice. They write more. They write more longer comments. They write different kinds of comments. But in terms of the conversation quality, what we think about this in practice, most of our metrics suggest it's worse. So really, it's not helping us in practice. I think AI assistance is more nuanced than we want to give it credit for. So really, we have to think about there's no one AI assistant. There's no one agentic AI, and that the effect for this, we really need a holistic one. There's no one metric that's going to tell us whether it works or not. So for this talk, I talked about how we might steer models to different kinds of behaviors or take on different kinds of perspectives. I talked about how we might get the AI system to help us behave in certain ways, behave better. So if I want to summarize, can we get AI models to act like specific groups of people? Not really. So it doesn't really work. This agentic system doesn't help. Can we make AI assistants most helpful in practice? Maybe the most helpful is to not use it right now. I still think there's probably better ways to think about the context in which this might be most helpful. And in terms of what do we want to do next, I do think most of our experiments still have been mostly in English and in Western context. We have to think about the global population of people that are using this. We have a US representative sample, we do not have a globally representative sample. And so there may be other ways that we can think that these tools are especially assistive. People who are working in English as a second language, maybe this is a really enabling tool for online conversations. So I think there's lots of opportunities there. We do need models that are better able to mirror real people, and this is going to require so much more data that is not present currently. So I think we have to be more careful and conscientious in the way that we create AI systems, who's present in that data. And then again, thinking about AI assistance in context. Who is it useful for, and when is it actually useful? So I want to encourage you as you build these AI systems here at UB, like where do we actually want to deploy this? With that, I have to take a few questions, and there's a lot of collaborators who did a lot of stuff with me on all of these. So thank you very much.
Thanks a lot for the amazing talk. I am seriously evaluating on my recommendations again. We open the floor up for a few questions, followed by some snacks and coffee eventually, if you want to talk about AI. We've talked about the prompts for the agentic AI. Do you think there will be better predictive performance if we fine-tune the agents on some domain-specific data sets that we know for sure that's not in the training data set?
For the last system or the just in general?
Just in general.
I think so. It's really tough to predict this, though. I feel like all of my assumptions for what was going to work didn't play out, just because of the changing model landscape. I do think if you, so to give a few examples, I think if you train the models for offensiveness, I don't think we have enough data to train them to really take on good perspectives. I think if you're training the system prompt to do really well in general across a bunch of tasks, that should actually work. We've seen some ongoing work that suggests that that's definitely going to happen. For like the conversation one, I don't even know if we could train it to build a better conversation tool yet. But happy to chat about that more too.
For the last one, do you think age group and say application where it could be used, would that consider like would that be a reason for let's say we have younger age group that would not consider AI as much useful as people those who are most in the working group or that kind of?
Yeah. So the question is are there like, I'll say generalized, are there demographic characteristics that might explain some of this? That old people are like, I don't know how to use AI, I'm not going to use it. That doesn't include anyone here. We did do a regression, actually. So we collected all this demographic data, too. It does not seem to be the case. So there's not age or gender confounds with any of the different types of treatments, as far as we could tell. Maybe with more data, we could get more power, because I do suspect that there's probably something there. We only had like 680 people in the study. It's a great question, though.
I was struck by the negative that you got.
Yeah.
Is it just that LLMs just really don't know how to categorize? I mean, like how to say this is from this style. I mean, I'm just thinking like it has to go back to the data and say who's speaking, right? Who's giving this talk.
So the question is like, why do we get all these negative results? Yeah. So I think there's two things going on. I think one, the safety tuning that models have to try to avoid presenting biased responses with regard to different groups. I think some of that has washed out some of the ability for models to really do this perspective-taking kind of task. I think the second thing is the models themselves are really good at objective questions and creative things. So you ask it to write a story, you're like, wow, it looks like it's really good. For these kind of subjective behaviors, the models are much worse at for trying to get the kind of human variety of the way that we might respond to it. So if you're looking for diversity of responses, I think it's not really, they're not there yet. They're not able to do it. Hopefully they will.
You've spoken about system prompting and how it's been useful for the generation. So we've heard about fine-tuning, these type of LLMs for a specific task. How do you fine-tune system prompts for a generalized task?
So, well, if you wanted to fine-tune a system prompt, you would take your task instructions and just stick the system prompt in front of it, and then just do regular fine-tuning, and it should actually work. We haven't tried that in practice. We've sort of been trying to think about models that are not, it's not easy to do, or if you want to just run it in general on a bunch of different tasks. But you could do that in practice. You could definitely fine tune just by appending it or prepending it to what you want to do.
I have one quick question. So I know you might have to postulate for this because it might be leaked from this particular area, but LLMs are not good at taking certain perspectives or trying to mimic certain demographics and so on. Are they, in your opinion, good at identifying biases in content that's supposed to be objective? So for instance, with news articles, are they good at identifying things like hyperpartisanship or biases there?
Yeah, so for trying to identify certain kinds of biases, I think they're okay at it. The one thing that gives me some pause is how easily they can be convinced to change their view. So you could ask a model for something that's wildly biased, please generate an explanation for why this article might be biased, and it will give you a nice report. And you're like, I would agree with that. And you say, if you type in, no, actually you're wrong, it's unbiased, please explain why. It will generate another nicely formed report explaining why this is an unbiased article. And so that requires the end user, us or you, someone else, to say which of those is the ground truth in terms of bias. And I think it creates a lot of challenge for thinking about objective evaluation of a more subjective kind of task. But I think the reasoning process is probably the way to start. For getting it is, can we trust those outputs?
So this is a follow-on comment. How does one get a sense of what those hyperparameters that are guiding the prompts, what they are, what the impact of those secondary parameters are, and are they stable over time or are they dynamically changing? Then the last part is, what's the implication for trusting the output in terms of asking for objective information if there is a shifting context potentially?
Yes. So we've looked at this. This is one of the things that we're looking at now. Is like, you could think in the olden days of BERT, modern BERT, if you will, even. You have some content and you're going to train it for a particular objective, and that's how you update all of your parameters. But for these large language models, the prompt itself is almost like fine-tuning at inference time. They call it inference time training or inference time rollout. And I think that we've tried to study what's the effect on the parameters of these large models for better system prompts. Is it moving it in a particular activation space that suggests you can do better? And it is happening that, like, if you compare task optimized prompts like Protege, it moves it in one direction, and if you do systems, it moves it in a slightly different direction that's closer to where you would get better performance as a whole. That said, it is wildly hard to figure out how to deal with all of this. I think some of the mechanistic explanations for these models, like what are they doing internally, is maybe how we would get at it. In terms of stability, that's also like, I honestly don't know how to do that just yet. Because the models are, we often are used to thinking about large language models or any model. You get one answer and it's done. But these are more iterative and they're interactive, and that really can change what the answer should be and when you stop getting the answer. And I wish I had a better answer for that one.
So my question is most related to training the LLM model. So sometimes when I train model, a little change in a prompt change the output a lot, and sometimes a big change in a prompt doesn't change the output at all. So I will test the query one at a time, but the next time I test it, it has a different output. So how do you ensure that the model remains stable and it gives the perfect output to the community?
Yeah, that is a great question. So models, let me see if I can answer this in two brief ways. I think one, I'm not sure if there's a good way to understand how much we can change the prompt and not have significant effects on the output. Models are really sensitive to adding multiple periods or multiple spaces, things that no human would ever say should change your answer. In terms of the instructions, I do think that what your approach is doing is try a few different prompts and see which one works best on some held out data. That's actually the way that we have to do it currently. I don't know if there's a better systematic way yet of trying to understand how do I construct this prompt to give me robust, reliable answers. And even, I will say one thing that has been useful for us in practice though. So most of these models, it's a probabilistic output. You get a probability distribution over output tokens. And controlling how you sample from that is a temperature parameter. One of the things that's been really useful in practice for us that I think is becoming a standard guideline is rather than taking a single output to choose a set of temperature ratings and sample repeatedly from that, particularly if it's a deterministic output, or not a deterministic, a single evaluation output that you're looking for. You can use that to get a distribution over answers from the temperature setting of the model that it gives you a better sense of like, is my output stable? Is my prompt giving more stability? And we've used that as a selection criteria for prompting as well. But it's a really hard, you should, if you want to solve that one and have a really high impact dissertation, do that. We all love you for this, for sure.
So do you think training on more data will enable the LLM to mimic different demographics?
Yes and no. So I think if we continue our current training, no. Like I think if GPT-5, no. I think it's going to take more curated data, and I think that takes both like broader participation in how we label data. Like all of us have very different views on certain things. I'm not sure which things. And how do we surface those differences to train on the model? I think there are more recent efforts. So the new Olmo models out of AI2, I think have a much more open way that we might be able to incorporate global voices into how we think about what perspectives models can take. So I don't think general training, more data, it's really targeted, curated data that represents a broad diversity. That's what's going to be needed. And that data does not exist. What I wish it did. Well, I'm happy to take more questions in the snacks too. So.
That appears to be the end of the Q&A, and we still have coffee and we still have people if you have any more questions. As it turns out, we do have that more.
Excuse me. I have a question.
Oh, hey.
According to you, what's the best way to avoid hallucinations?
That's a great question. So it depends on the kind of hallucination you're concerned about. So I think that if you're looking to do like retrieval guided, one of the things that we've done is try to ask models to cite its sources and then to cross-check that with another model that can actually retrieve those sources and do that. So it's a more complicated process if that's a concern for you. It also depends on the domain itself. Maybe we could just chat after this, see if you have a particular application, how to help.
I have tried that, using that,
Mm-hmm.
but now I'm trying to create diabetes management chatbot, but also it includes a lot of domain knowledge, and the model gets confused sometimes because it has to track the patient's past results, like glucose levels,
Yeah.
all the data. So there is a high possibility that you get confusion between the data and the numeric values.
Oh yeah, so in that particular application, I would not be surprised if models hallucinate numbers there or change the number values. So I can send you a paper too. So my colleague Lou Wang's did a lot of this where you retrieve, you generate, and then you can verify or reject summarizations of the RAG system to prevent hallucinations. But it's more bespoke. So I don't think it's like a general technique, but there are techniques that for that kind of application where it's going to hallucinate wild kinds of stuff. Yeah. Yeah, cool. Cool.